Alright, in this video we are going to be using the radicals in a specific application that we use quite often, and that's with solving right angles triangles with the Pythagorean theorem. First off, when you have a triangle, and specifically if you have a right triangle, meaning this angle here has to be 90 degrees. If you have that, it turns out there's a relationship between the sides of the triangle that is fairly powerful, meaning that if I know two of the sides, I can figure out the third side. Just before we get to the formula, though, I wanted to just get some pieces of the triangle so that you know them. This longest side, the side that's opposite that right angle, we put the right angle there again, the one that's opposite to that is known as the hypotenuse. So the longest side, the one that's opposite the 90-degree angle, that one there, so this side here is known as the hypotenuse. Then the other two sides, we don't really have names for them. Guess we could name them if you want, but we just call them, they're a leg. If that's a typical name for them. Now, we can also identify some letters with these, and these are typical letters, but like in Math 95, we use X, Y, and R instead of A, B, and C, but really the letters don't matter, but where they are does matter. The hypotenuse, typically we label that as side C and lowercase c. Then the other two sides, it doesn't matter. Let's just make that one A and this one down here B. Now, if you want to label the angles too, and we're not dealing with the angles here, but when we do trig, that'll help you. The side that's, or the angle that's opposite the side there has the same letter. So this one that's opposite to that is angle C. And then angle A must be their side A, so the angle opposite, this one here must be angle A. And then, of course, lastly, this is side B, so the angle opposite that one is angle B. Just as a point of note, if you want to look at the measure of the angles, all the angles in a triangle must add up to 180. Not just in right angle triangles, but all of them. But we won't use that fact here in this scribblecast. Okay, so the Pythagorean theorem says that if you take this side and square it, and then take this side and square it, and then add those two, and take the square root, that'll give you the other side. Or it's c squared, the hypotenuse squared, is equal to the sum of the other two sides squared. Now, let's do this actual example here. So I've got A is 6, so I'm just going to plug numbers in. C I don't know, so I'll leave it as a C. A I know is 6, so that's 6 squared, plus B I know is 8, so 8 squared. So 6 squared is 36, plus 8 squared is 64, so C squared equals that plus that. So C squared is equal to 100. And then to solve that, we use the square root principle, which means if you square root one side, you can square root the other side. It's sort of opposite to that principle of squaring that we saw in the last section. So I'll square root this side and square root that side. The square root of this side is a c, and the square root of that side, of course, is a 10. It's actually a positive or a negative 10, but when we're dealing with lengths of sides, there's not a negative in there. So really the answer for that side is just a 10. Let's try some. If you're feeling good and you want to try it on your own, have at it. Okay, so this one, c squared, again, I don't know c. A is 6, so 6 squared is 36. Plus 12, oh, maybe I should do the whole way, right? 6 squared plus 12 squared. So that's 6 squared is 36 plus 144. So c squared is equal to that. So when you add those, I think that's 180. So 180. So c squared is equal to 180. So now I have to take the square root of both sides. So c is going to be equal to a plus or minus, but we'll just do plus of 180. Okay, I've got to bring back my calculator here. New calculator, eh? Uh-oh, it's not going to work. Just give me a second. Okay, here's my calculator. Hopefully you can see some of it anyway. All right, so what was I doing? Square root of 180. So square root is of 180. Go. 13.416. So in this question, I would say my exact answer is 180, and then my approximate answer, what was it? 13.416. And maybe I'll round that, 13.416, maybe let's call it 14.2. There might be a question where they tell you round it to 2 decimal places or 3 decimal places, whatever. Okay, here's another one. Ooh, this time I know C, but I don't know one of the other legs. So let's plug numbers in. C squared, so it's 25 squared is equal to A, oh, I don't know A this time, plus B, 21. 21 squared. Okay, 25 squared I think is 625 is equal to A squared plus 21 squared I think is 441. So then A squared, if I subtract 441 from each side, I'm going to have to figure that out. 625 minus 441. 625 minus 441 is 184. And then I need to take the square root of that. Of 184 is 13.5. Let's call it 13.6. So A squared was equal to 184, right? And then I use the square root principle on either side. And I got, what did I get again? 13.6. So A is equal to 13.6. Okay, hopefully you're getting on to those. Lots of different ones. Here's another one. They just turned the triangle a little bit. But all you have to do is, hey, there's the hypotenuse. So it's going to be 20 squared is equal to, and these doesn't matter. Let's call this one A and B. I guess they call this one W. So they're using a different letter, which is fine. So let's call that one A. So this would be 12 squared plus, oh, that one I don't know. So, wow, let's call it W. Okay, 20 squared is 400. 12 squared is 144 plus W squared. Subtract 144 from each side. So I think that's 256 is equal to W squared. And then square root both sides. So you get W is equal to the square root of 256. And the square root of 256, I believe, is exactly 16. This one, they say give an exact answer and an approximation. Well, this one comes out exact. So 16 would both be my exact answer and my approximation. In this question before, this one here would be the exact answer, and this one here would be the approximate answer. Okay? All right. Oh, this is an interesting one. Solve the length of B. Okay, that's my hypotenuse, and then, well, let's call this one A. So C squared, so it'll be root 11 squared is equal to A squared, that's 1, plus B squared, that's what I'm looking for. So root 11 squared, the square root and the square cancel, so this would just be 11, is equal to 1 squared is 1, plus B squared. Subtract 1 from both sides, so I get B squared equals that. Square root both sides. I get B is equal to root 10. That would be my exact answer. And an approximate answer, I'd have to go back to my calculator. Hopefully it still works. And do the square root of 10. 3.2, let's call it. So B is equal to 3.2. Lastly, I won't solve these questions, but I'll just help you set them up. These are set up perfectly for doing word problems. So series of guy wires to be attached 20 meters up on a tower. Here's the tower, guy wire, sort of a supporting wire. Okay, and it's then I'll draw a line along the ground here. Now they say if the wires are 30 meters long, so these are 30 meters long. Oh, and it says they're supposed to be attached 20 meters up on a tower. So here's my tower, so this would be 20 meters. And then the question is, how far from the base of the tree must be attached so that you get a right triangle, so that it's perfectly vertical. Mine's not perfect, but so they want to know what this side is here. Let's call that B. Okay, so off you go. C squared equals A squared plus B squared. Plug in the numbers, away you go. Okay, last question. Cat located at the top of the tree is taunting Taylor with a slingshot. Darn cat. Okay, here's a tree. The height of the tree is 16 meters. And the distance from the boy to the base of the tree is 24 meters. So, and here's the boy over here. Okay. And the question is, how far will he's got a slingshot. So whatever he puts in the slingshot, maybe it's a catnip that the cat's going to catch. Well, whatever. Anyway, and they say distance from the boy to the base of the tree is 24. So this distance here is 24. And they want to know how far the catnip will travel. There we go. So this side here is the hypotenuse. That'd be like c. C squared equals a squared plus b squared. A maybe is this side, so 16 squared plus 24 squared. Add them up, take the square root, you get c. Okay, so in this section we have looked at just one tool for examining relationships in a triangle, specifically the relationships between a hypotenuse and the two legs of a triangle. And that relationship was the Pythagorean theorem, or Pythagoras' theorem, c squared equals a squared plus b squared. Try some